I want to talk about colour. So colour is quite a different division of fireworks from black powder. And so what, in fact, we're doing is getting a chemical that will provide the oxygen, an oxidizing agent, in this case potassium chlorate. We then add a fuel that will do the burning. And then we add preferably an insoluble chemical of that metal which creates that colour. Strontium for red, barium for green, copper for blue, and we don't bother too much with sodium because sodium atoms produce yellow flames anyway. In fact, sodium is everywhere and it's difficult to get rid of it, basically. And then we add chlorine to it as best we can so that we produce a chloride. Now, in that flame that you see, there, let's say it's red and it's strontium chloride. The strontium chloride in that flame, and it's not a stable molecule, it only exists in that flame. And what is happening, according to the theory, is that the atom is, as all the electrons on the outside get more and more excited as it gets hotter and temperature goes up and more, and then they throw out a lumen of light, and in that case with strontium it's red light. And so that's really what colours are primarily doing. So if, for instance, then, we were going to make, say, red, then we have to obviously produce those particular chemicals I've been mentioning. And in here, I've just got 4 little bits of coloured material from typical fireworks. And in 1 or 2 cases, I'm going to add something on the base as well and show you what can happen. So let's take a little bit of stuff here, first of all, and let's then take what is a red, part of a red firework, like you saw on that rail there. And you see, I'm sorry, I picked the wrong one up. That's yellow. Never forget that. Let me find the red one. Yes, that's the red one. Now you see, that is a normal red, and you might even describe it as even pink. But look at that. Sorry. Now what you've done really, in that particular case, this is a bit complicated, you've actually used there the normal sort of things we use. But here we've taken the potassium out of it and replaced it with ammonium compounds. And so you get a deeper red because potassium is purple and colours the red in a slightly different way. So here we go, say, with green. So that's barium producing that kind of flame. And here is blue, but I'm going to show you another blue as well, because blue is very difficult to make. It tends to look white at a distance in the modern way that we use it. So we'll have a go with that one. So let's have a look at this blue to start with. And look at that blue. See, they're tending to show a kind of whitish sort of colour with blue, and particularly in this atmosphere. In the dark, you'll probably find that it looked a better blue, and you'll probably also find that if you put green with it, you will be deceived into thinking that it is in fact a better blue. Or if you were to mix, say, blue and red, then of course you would get a kind of violet. But in this kind of situation, these colours are not as good as they are in the dark, because fireworks are like people, really. Distance lends enchantment.